Hi guys, this is Mr. Muhammad, and today I'm going to work out some problems concerning combinations, permutations, counting principle, etc. So for the purpose of this video, I'm not going to teach you the lesson from the beginning, so you need to go back to your notes and learn everything that we took in class, and then come back and reflect on those problems. And I advise, if you're going to solve these problems first before you actually go ahead and see how I solve them, and then check the answer. So it's better this way. So let's talk about the types of questions, the question types that you may see, and most importantly are in the book that we have. So first, multiplication principle of counting, very important, how to count using the multiplication principle. And like examples like the license plates, like the phone numbers, like when I give you a certain amount of letters and I ask you to place them in certain ways, with repetition, without repetition, with certain conditions. For example, if you can't start with 0, if you can't start with a vowel or those letters. So you need to know that, for example, the number of letters are 26, a number of numbers are 10, starting 0 and ending 9, and all this kind of stuff. So that's just counting and knowing how to count. The next one is number of ways an event happens using all sample space. And to explain this, I mean, for example, if I want you to seat 5 people on 5 chairs, so that means the number of people are equal to number of chairs, so we have to use them all every time. The next type is number of ways an event happens in general, which is like permutations, where order matters. So when I tell you that order matters, or the question tells you somehow that order is important. Like, for example, if you're electing for positions like a president, vice president, and a secretary. So order here matters for positions and any other thing. And sometimes it's actually explained in the question really explicitly, that they actually want the order to matter. Next is the opposite, what order actually doesn't matter, which we call combinations. So like, for example, choosing a number of toppings for pizza, or choosing toppings for a sandwich. The order doesn't matter. If you put, for example, the lettuce first and then the jalapeno, it doesn't really make a difference, I mean, in this sense. And just remember that these are just basic ideas. There's more than that. So there are other ideas that we can encounter as well. So the first question I have here reads, suppose that 2 dice, one red and one green, are rolled. How many different outcomes are possible for the pair of dice? So this question is like really easy when you look at it, but you might ask yourself, like, okay, so why are there one red and one green? Like, what does it matter? Why is it important detail that he tells you? The important detail here tells you that you can actually see which is which. So when you deal those dice, so you know which one is red, which one is green, so it's easily distinguishable. So the first, if I roll the first one only, the red one, the number of possibilities are only 6 possibilities. And if I roll the green alone, so the number of possibilities are also 6, because you can get 1, 2, 3, 4, 5, 6. But at the end of the day, if you roll them both together, you can, for example, get 1 on the red and 6 other choices on the green. But also you can get 2 on the red and 6 other choices on the green. So basically what you're doing, you're counting the number of possibilities. You multiply the first sample space has 6 possibilities. The other one has also 6, so you multiply by another 6 possibilities. So you get at the end 36 outcomes. So if you're interested in knowing how many possible ways you can deal those dice, you can get 36 outcomes. Alright, so next question also is about counting the possibilities. But this question is really famous about license plates. It says, how many different license plates begin with 2 digits, so you're going to start with 2 digits, followed by 2 letters, and then 3 digits if no letters or digits are repeated. So that means in these two, in the first 2 places, you're going to fill it out with digits. 2 digits. Okay. And the last 3 are going to be, the last 2 actually, supposedly it's 7 or 6. Let's see. Begin with 2 digits followed by 2 letters and 3 digits. That's 7 actually, not 6. So we have to add one more space. Yeah, that works. So then followed by 2 letters. So I have here, the green ones are basically letters. And the last ones are going to be 3 digits again. 3 digits with no repetition. So the way to think about this is no repetition means not every space is going to get the same value. Again, like for example, if I start the first digit as 9, so the second one cannot be 9. And also the 3 digits at the end cannot be 9. So the way to think about this is the first 2 digits, how many possibilities do you have? You have 10. 10 different numbers you can choose from. You can choose 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 10 possibilities to choose from, so that's fairly obvious. But the next digit though, if I choose any of them, this one cannot be repeated. So I have to remove one of those possibilities, I will end up with only 9. So that would be times 9. The 3 digits at the end shall not be repeated also, so it has to be reduced by 1. So if I have now 8 possibilities and 7, 6. So these are the possibilities of numbers. In the middle, we have 2 letters. So the letters in English are 26 letters. So if the first one is 26, the second one, without repeating, will become 25. So to solve this, you need to multiply all these numbers together. So you multiply 10 times 9 times 26 times 25 times 8 times 7 times 6. And if you do this with a calculator, of course, you're going to get 196560000. And that's, of course, a lot of license plates that can be generated using this method, using this pattern. And as you can see, this is 3, so you have 19,656,000 different license plates. And of course, if you add in color, you're going to get even more than that. So this is just one way to use to generate license plates. All right, another example, we have a coin toss experiment. How many different sequences of heads and tails are there if a coin is tossed 10 times? So if I want to toss a coin 10 times, how many different sequences of heads and tails? So the thing is, we have to give ourselves an easy example first. If I toss a coin only once, what are the possibilities? Only 2, right? So if I toss one coin 2 times, I have 2 times 2. That's 4 possibilities. And then 10 times, you end up with 2 times 2, 10 times, which is basically 2 times 2, but 10 times. 2 to the power 10 you end up with. So the possibilities or the number of different sequences you can get by tossing only one coin 10 times is 2 to the power of 10, which is 1024 different sequences. Different sequences. All right, one more coin toss problem. We have a coin is actually tossed 20 times and the heads and tails sequence is recorded. From among all the possible sequences of heads and tails, how many have exactly 7 heads? So the thing is, this question is pretty similar to the one that you have to choose, for example, a word, and you need to know how many if the word has any repetition, you need how many words, how many unique words, distinguishable words you can make out of those letters. And remember that Mississippi example that we took in class. But this time it's not a word. That's why it's disguised. It's the same idea, but it's disguised in a different example. So the way you think about this is you have a coin is tossed 20 times. 7 of those times you want to be heads, right? So the sequence has 7 heads. So if the sequence has 7 heads, it must actually have 13 tails. That's the only possible answer. So 7 heads and 13 tails. How about if you think about it, all of them are different outcomes? Let's say like A, B, C, D. How many are they? 20. So the answer should have been 20 factorial. 20 factorial is the answer if all of these outcomes are different. However, here we have a repetition. And to deal with this, we need to eliminate any repeating. So I'm going to divide by 7 factorial, which is the repetition of the heads, times 13 factorial, which is the repetition of tails. Think about it like a 20-letter word that has 7 H's and 13 T's. So if you deal with number of possibilities or number of permutations, in other words, how to arrange this word, you have to make sure that you do not count any repeating ones. Okay, so if you do this, you're going to end up with, if you do this on the calculator, you're going to end up with 77,520 possibilities. So basically that happens a lot because you're tossing the coin 20 times. But of course it's much less if it's 20 factorial. All right, next question is pretty straightforward. It's like a choice kind of situation. So let's go back. So it says Indiana Jones and the final exam. Professor Indiana Jones gives his class 20 study questions. So you have 20 study questions. All right, let me erase that. 20 study questions from which he will select only 8 to be answered on the final exam. How many ways can he select the questions? See, the way you look at this is you have 2 choices, either using permutations or combinations. And you have 20 questions and you're choosing 8. So the answer must be somehow either 20 P8 or 20 C8, right? So which one to choose and how can I make a decision? Thing is, you're choosing questions. You ask yourself only a simple question. Does order matter or not? Of course, if you're choosing questions, the order does not matter. You can choose any 8 in any way. It doesn't matter which one you choose first or which one you choose last. It doesn't even matter. So I'm not going to go with the permutation because it doesn't work in this example. So the answer is pretty much the yellow one, which is 20 C8. And if we apply the formula, it will be 20 factorial over n minus r, which is 20 minus 8, factorial times r factorial. So simplify this, becomes 20 factorial over 12 factorial, 8 factorial. Okay, so let's use the calculator to find that out. So 20 factorial over 12 factorial times 8 factorial. So this gives 125,970. So it turns out that this Indiana Jones teacher has 125,970 ways he can choose questions just out of 20 questions. He can select 8 how many times? All that time. Of course, if the question was only permutation, it would have been more because you're actually calculating exactly in which order. So instead of dividing by the 8 factorial, you're not going to do that, so the number will get bigger. Actually, to give you an idea, the number will be 5 billion ways. So it's just like 5 times 10 to the power 9, which is pretty huge. What do we have here? Electing officers. So you have 13 members of the East Bernard Garden Club are electing a president. So the first position is for a president, vice president, and a secretary. So you're choosing 3 positions, 3 posts. Okay? From among their members. How many different ways can this be done? So again, it's either permutation, choosing 3, or combination, choosing 3. So you ask yourself the basic question, is it concerning the order or not? So as you can see, you have to choose officers. So you're going to choose a president, a vice president, and a secretary. And these positions, of course, vary. They are different. So I cannot just choose any 3. I have to choose in order. The first one becomes the president, the second one becomes the vice president, and the last one is the secretary. So order here matters, obviously, even without telling you explicitly. So it's implied in the question. So basically the answer will be, I have 13 members, and I'm choosing from them 13p3. Applying the formula, so you're going to get 13 factorial divided by 13 minus 3 factorial. So you're going to end up with 13 factorial over 10 factorial, which is, if you want to do it by hand, just as revision, so it will be 13 times 12 times 11 times 10 factorial over 10 factorial. Of course, I'm doing this to eliminate the 10 factorial, so the answer becomes 13 times 12 times 11, which is equal to 1,716. So out of 13 people, 13 members of a club, you can actually have 1,716 ways in choosing 3 posts. So the odds are a little much in this case. So the next question is pretty important question about the seating arrangement, especially in circles. And before I answer that question, I'm going to go ahead and talk a little bit about another idea. What if I want to place people or beads in this example, but not in a circular way, in just a linear way? So let's suppose that I have 4 seats, and I want to arrange people to sit down in those seats. So I'm going to put one person here, one person here. Okay. And let's make them also different colors. Okay. And this one black. So basically I want to seat 4 different people on 4 different chairs. That's basic permutation. And you know the answer is 4 factorial. So you have 4 factorial ways of actually seating people in one chair. So you have 4 factorial number of ways you can seat 4 people in 4 chairs. But the problem is when it comes to circular arrangement. So suppose you have a circular table and you're trying to seat 4 students around those tables. The first one who comes in, so the first person, actually doesn't matter where he sits. You have only one way, you have only one possibility that this person sits, because whoever comes next can sit anywhere and it will be the same because he can see the same thing. So it's only one way. So that's the problem. And instead of having 4 factorial number of ways of seating those people, you have 4 minus 1 factorial of seating the others. So basically you're going to exclude one possibility from those 4. So the answer to this question, let's read it first. It says 4 beads, red, blue, yellow, and green, are arranged in a string to make a simple necklace as shown in the figure. How many arrangements are possible? And he didn't specify anything about any 2 colors that shouldn't be adjacent, so there's no restrictions here. So the answer should have been 4 factorial. But for circular seating or for, circular arrangements, it has to be, the formula is P n is equals to n minus 1 factorial, and this one refers to the first bead. Okay, so I have how many beats? I have 4 beats, so P4 becomes 4 minus 1 factorial, which is 3 factorial. So 3 factorial, you have 3 times 2 times 1 gives you 6. So the answer to this question is you have 6 ways to arrange 4 beads in a circle. So that's it for this revision. Please solve all the examples that we've done in class and also watch this video, it's very important. And if you have any questions or any concern, just let me know so I can also help you with that. Good luck. Also remember that you have another lesson to work on, which is the binomial theorem. So it's not just this one. So this one just because it's a little bit of complicated lesson, but you have to also work on the binomial theorem. Okay, there will be no revision videos for that.